you've kind of made a very, I guess, progressive argument that perhaps death isn't as inevitable as we all thought, but perhaps this can be considered as, I guess, kind of a problem to be solved. And to some people listening to this, that claim is going to blow their minds. So I'm just curious, what prompted you to make that case?
Starting with the motivation, it's like, why would anyone want to tackle the problem of death? I think it's quite obvious if we think about individual things that cause us to die. Nobody asks this question if it's like, why do you want to cure cancer? Or why do you want to deal with heart disease or any particular disease? But it seems like when you look at death overall, often it doesn't come up. People think that when they're older, perhaps they'll accept the fact that, death is a natural and inevitable part of life. But I've always found that a little dubious. And indeed, when you start actually looking into the data of what people think when they're on their deathbeds, what you see is that most people, even elderly people, still in their last weeks and months of life, have a very strong will to live. So if you go into hospices and you survey the terminally ill on what their will to live is, you see something like 70% still describe a strong will to live. And I think that's because most people, if they had the option to live longer lives in good mental and physical health, would choose to keep seeing their friends, pursuing their goals, spending more time in the sun. So that's essentially the motivation is like, I think it's a tragedy that we are limited to the lifespans that we have at present with not a huge amount that can be done when we get towards our elder end of year points. So then the question is like, but what can actually be done about it? Like what makes me think about that? And that's more a set of ideas which I think one thinks about more if one is inclined to investigate neuroscience and philosophy, but particularly if you have a bit of an interest in science fiction to begin with. Because in science fiction, an idea that's been explored for a long time is this idea of like something like cryosleep or cryostasis or other ideas where you could somehow take someone, put them into kind of stasis in a pod or something for a period of time, and then pull them out like years or decades later and restore them to consciousness, restore them to health. It's an idea that's been explored in science fiction for at least 50, 60 years or so. But it seems to have remained fully in science fiction. And I'd seen very little scientific and philosophical analysis of when something like that, if it could ever be possible, when it might become possible, and what are the actual barriers to producing something like that. And so essentially the book starts with the motivation. People want to extend their lives. And the question, could something like this ever be done? Could some sort of stasis ever be produced, which would be able to take people of today who are dying and somehow maybe keep them around so that they could benefit from future medical advances which haven't yet become available?
You mentioned sci-fi and certainly, even for me that had been very exposed to this topic, I mean, when we get into some of the things we'll discuss today, from, as you mentioned, some of these freezing techniques to different preservation techniques to reviving people, there's so much to get into here today. But I really want to kind of start off, one of the kind of first things to kind of really highlight the point that you made there is this kind of palliative philosophy that you discuss in the book. And I wonder perhaps if you can, I guess, go into that a little bit more, and then we can kind of start, I guess, deepening the argument.
Palliation is a form of care provided to people when you can't address, for whatever reason, the root cause of some medical issue. So instead, what you do is you try and address the symptoms. So it's most commonly thought of in cases where you might have someone with an incurable terminal disease, like, for example, a metastatic cancer. And while the cancer can't be removed because maybe it's near a critical blood vessel or nerve or deep inside someone's brain, what can be done is you can provide treatments to try and alleviate the symptoms of the disease. For example, with cancer, maybe chemotherapy won't cure the patient, but it will reduce the size of their tumors and thus provide some symptomatic relief. And that's we always want to be improving the welfare of people. So palliative care, even in circumstances when we can't cure a disease, is still very, very important. But Obviously, cures are better than masking symptoms. And what I think there's a few times in medical history, we've seen examples where people have confused an inability to cure something with something being actually a necessary part of life or nature. And they've become more focused on trying to provide comfort through palliation than necessarily attending to methods of curing the problem. So I talk about it primarily in the book in the context of death, where I think we focus on ideas like death is natural, or death provides meaning to life, or death is good for society. I think those are more palliative ideas, things that make death more comfortable for us in the face of not being able to do anything about it historically, and it being a tragic part of life. Because I think it's easier to accept the inevitability of death if one feels it has some purpose, rather than if it just induces existential despair. And what an interesting analogy for this is, and what I go through in some detail in one of the first chapters of the book, is that I think this was also the attitude people had about pain in surgery prior to the development of anesthesia. So back before the middle of the 19th century, if you needed to have some painful surgical procedure, an amputation or a tumor removed or something, there was little that could be done to alleviate the pain. But in that circumstance, it wasn't the case that your surgeon would necessarily say, look, I'm so sorry, it's going to be super painful. It just sucks. Like, there's nothing we can do for you in that circumstance. It's just bad. Some would say that, but some would actually say, actually, the pain is a necessary part of the surgical procedure. It's actually important for the healing process. You need to feel the pain, or the patient needs to feel the pain for it to all go properly. And when anesthesia was first developed in, I think it's 1846, it was first demonstrated, you actually had some doctors and surgeons immediately after the development of anesthesia saying that it was heretical or bad for the patient, or in other ways, like not actually something that we should be desiring to add into medical care. Now, obviously, quickly anesthesia did become the norm, and today you would see a doctor is insane if they ever suggested that like anesthesia would be like something undesirable for a patient undergoing a painful surgery. But I think it demonstrates a circumstance where, because historically they couldn't do anything for the pain, they produced a kind of what I would describe as palliative philosophy, a philosophy which made it easier to bear, even if it couldn't deal with the underlying problem. That's the idea.
And in terms of aging and, I guess, diseases, of course, most diseases are highly correlated with aging. You know, no child comes out the womb with dementia. Age is, of course, a massive risk factor for heart disease, for neurodegeneration, for cancer. As I mentioned, you know, it's not a new idea to discuss that if we, for instance, try to treat aging as opposed to spending much of our time treating specific diseases, then that seems to be a reasonable way to go. However, as you describe in the book, I believe, if I remember correctly, there's something like only 1% of funding goes to aging research. Is that right?
Yeah, it's a little hard, depending on how you do the maths and calculation, to work out what fraction of all medical research spending goes to fundamental anti-aging research, or basic aging biology, not even anti-aging research. There's a comparison I have. I think it's looking at the National Institute of Health's budget in the US, and particularly focusing on the National Institute of Aging, where you see it's only a very small fraction, a couple of percent, I think, of the budget that goes to like fundamental aging biology, understanding why we age, what the biological processes are, as opposed to, as you say, a lot more money which gets spent on treating diseases of aging, things like cancer, dementia, heart disease. And as I put in the book, I've always found it a bit more strange that we're spending more money on the equivalents of fire escapes and fire extinguishers than on actually ensuring things aren't flammable in the first place, or in this circumstance, trying to treat the symptoms of aging, things like cancer and heart disease, rather than trying to ensure, you know, we come up with ways of preventing those things from happening in the first place. And indeed, it's one of the key parts of the book, where it's like, even if you don't buy my weird stuff about brain preservation, revival, uploading, whatever, like, I still think that we should be focusing on the fact that it seems like with medical research, what we want is like cures for diseases and treatments for aging. We spend so much money on this, but we're a bit uncoordinated when we think about it, where we think about removing individual diseases, but we're less good at thinking about risk factors for all diseases.
One of the kind of impressions that I got from the book is that modern medicine, as incredible as it is, it tends, of course, to be perhaps a little slow at times. And perhaps when we might need it most, the treatment that can really extend our lifespan, we don't know how far away it's going to be. So in terms of treatments that actually exist out there within the, I guess, longevity space, of course, I'm talking about things like pairing DNA damage, reversing cellular senescence, lengthening telomeres. How much of a significant effect can these actually have at this date and time today?
So I am not an expert on aging biology and aging medicine or gerontology, any of these related things. I have a strong passing interest, but I'll be careful with the comments I make. But to the best of my understanding, we don't really have any therapies yet that clearly extend maximum human lifespans in any sort of reliable way. Whether it's things like caloric restriction, which I think has come out recently as not necessarily being helpful for humans, maybe even increasing all-cause mortality a little bit. Whether it's the telomeres extenders, sirtuins, resveratrol, NAD+, whatever these like different drugs are. That's not to say I don't think they're worth investigating, and maybe some of the things we have under development will turn out to be quite useful in extending maximum human lifespans. But as far as I'm aware at the moment, the best therapies we have are exercise and good diets and picking your genes well in the first place. And that we don't have very promising anti-aging medicine already on the horizon, again, as far as I'm aware.
And that's a really interesting point because, you give an illuminating story at the beginning of the book about a lady that was type 1 diabetic and appeared not very long for this world and was, inching her way towards death. And then there's an example that you give where, we put the kind of the pause on her biology, and then a couple of years later, of course, insulin is around. I wonder if you could perhaps share that example and what you took away from it.
It's the story of Elizabeth Hughes, who in 1919, I believe, I'm really bad at remembering dates, 1919 was 11 when she was, as you say, diagnosed with what was then called juvenile diabetes, what today we call type 1 diabetes. Unfortunately for Elizabeth, though, at the time, insulin hadn't been discovered, and there were no treatments for type 1 diabetes. And so as a result, she had a prognosis of only something like 6 months to live or a few months to live. Because what would happen from that point onwards is her high blood sugar levels would just lead to worse and worse symptoms and eventually her death. Now, understandably, her parents were very upset by this and went looking for anything that they could to possibly treat Elizabeth. And they didn't find insulin, again, hadn't been discovered yet. But what they did find was a new therapy, which was starvation therapy. With the idea being that because the problem in diabetes is too high blood sugar, if you can keep someone on the minimum level of food and nutrition required to survive, you can sort of keep the symptoms of diabetes lower, and you can extend people's lives that way. And so Elizabeth went into this clinic that like very carefully calibrated her food, which kept her just from starving, but as a result also prevented the development of her diabetes further. And she ended up surviving 3 years in this state instead of just a few months. But what was incredible was at the end of this 3-year period in 1921, insulin was discovered. Elizabeth gained access to it. And as a result, she was then able to live something like another 60 years into her 70s with a fairly normal life thereafter, where she went to university, started a family of her own, did all sorts of things that no other diabetic child before her had ever been able to do. So I opened the book with that story for a few reasons. One is because I think it's a good example of how sometimes things which have always been inevitable and a natural part of life change. We can, from time to time, actually make impressive medical progress. And two is because the unpleasant limbo state that Elizabeth went through in the starvation clinic, I think is quite analogous to the process I talk about later in the book, this idea of preservation, which might be able to extend people's lives and buy them time until medical technology of the future becomes available.
Just kind of putting all that into one, that at the moment there really is no significant method that we know of that, for instance, can hyper-extend longevity, that can wipe away terminal illnesses. But it is a reasonable hypothesis to state that at some point in the future that there will be significant breakthroughs if we can get there.
It's kind of weird in that medicine is both very impressive compared to what it used to be and also quite bad at the same time. And I think it's hard to wrap your head around both of those at the same time, where every day, every year, we come up with new therapies for things that were previously untreatable, whether that's back in the 1920s when we developed insulin, or an example I used later from the book, these days where we're developing very impressive new therapies for previously untreatable cancers. Sometimes doing things like taking out patients' blood, re-engineering their immune cells to, with genetic manipulation tools to unblind their immune system to cancers, reintroducing them into people, and then curing diseases that were previously incurable. These things are incredible. But that being said, I agree. It is the case that we don't currently have any reliable therapies that can extend people's lives from the 80s or so that they normally get into their 90s, into their 100s. And the reason for that is, even if we could cure all cancer, let's say, that would on average only extend people's lives by something like 3 years. Because the problem is, as we get old, everything is breaking. It's not just that our risk of cancer goes up, it's our risk of heart disease goes up, our risk of dementia goes up, our risk of kidney disease goes up. All of these things get worse. And it's essentially because of humans are optimized in an evolutionary sense to live something like about 70 to 80 years. And beyond that point, everything starts to break, which means that in order to fix that, there's a lot of different things that you'd have to get right. Not an impossibly large number of things. Obviously, we can look to other animals like whales and tortoises that live a few hundred years. And that suggests that in principle, it should be possible to change biology so that it can last a lot longer than our cells currently do. But at the moment, we don't have the therapies yet required to do that reliably.
I guess perhaps before we go any further, it might be interesting for us to just really define what we're talking about when we're actually discussing death. So I wonder perhaps how you kind of conceptualize death.
Yeah, it's an interesting question, and one I spent a lot of time researching when I was looking into the book. Because I think ahead of time, a lot of people have this strong notion that medicine and philosophy always has a clear idea of exactly where death is and what the line is, where we think someone's alive and active, and then maybe they're sick, and then there's a clear point somewhere where a doctor can say, this person has died. But it turns out that it's actually often a bit more ambiguous than we would initially think, even to the extent that the definition of death used by the medical system has been changing over time as technology's advanced. So a bit of a historical overview, I think, is helpful. Prior to the middle of the 20th century, we defined people as dead pretty much as soon as they stopped breathing, because there wasn't anything we could do from them at that point. But with the invention of things like mechanical ventilators that could help people breathe even when their lungs had failed, and also with the addition of things like cardiopulmonary bypass machines that could circulate someone's blood even if their heart had stopped temporarily, we realized we needed a more sophisticated definition of death. So in the 1970s, particularly in the United States, there was the development of something called the Uniform Determination of Death Act, which was an effort by doctors and ethicists and legislators to come up with a more formal definition of death. And what they settled on was one based on two criteria, or two alternate definitions that one could use. The first was irreversible cessation of all heart and lung functions. And the second was irreversible cessation of all functions of the brain. Now, that was certainly an improvement over the lack of definition that existed before. But very quickly, doctors and other academics realized that there were quite a few problems with this newer definition as well. The first one, obviously, is that we don't really focus so much, at least in a philosophical sense, on irreversible cessation of heart and lung functions these days. While that's a useful marker often for when a patient has died in practice, in principle, you could always provide an individual with something called an extracorporeal membrane oxygenation machine, or ECMO, which is a device that's capable of taking someone's blood out, filtering it, removing the carbon dioxide, introducing oxygen, and returning it into patients. And we can use devices like these to keep people alive for days or weeks without functioning hearts and lungs these days. So instead, we mostly focus on the second part of the definition, irreversible cessation of all brain functions, or what's currently termed brain death. Now, what's problematic about this brain death definition is there's sort of two main issues. One is that if you look at the brains of individuals declared brain dead, but who are kept on life support, you'll often see that there are actually little bits of brain activity still remaining. Things like their hypothalamus, which controls hormones and body temperature, it might still be functioning. Now, doctors ignore this because they say, well, when we're talking about all brain functions, we don't really mean the hypothalamus. Like, that doesn't count. It's not important for consciousness or memories or anything. So we can still declare someone dead who's only got hypothalamus functioning remaining, because they're like, what's key to the person is gone. They'll never be restored to consciousness. But the other part of the definition that's a bit problematic is brain death is defined as irreversible loss of all brain functions. But the irreversible part depends on the technology of the day. Much as Elizabeth's diabetes was untreatable until insulin was developed, and a cessation of breathing and heart functions was irreversible until cardiopulmonary bypass and ECMO was developed, what currently counts as irreversible brain damage may not always stay irreversible. And we see examples today of crude devices, things like deep brain stimulators, things like the recent Neuralink implants, things like other brain prosthetics that are increasingly able to take over from brain functions that have been lost or damaged. So the question then is, well, what is this just going to keep happening? And if these technological developments continue, then how should we be defining someone as dead? And what some philosophers have come to the conclusion is that even if we had much better like brain implant neuroprostheses technologies than we have today, where someone still feels like they've been lost, where it still feels like someone has died, is when they lose their memories, their personal identity, their goals and desires, everything that makes someone uniquely them. So it's not when someone's heart stops. It's not when someone loses the ability to control their body posture or their body temperature. It's someone dies when they lose the psychological properties that make them them, and that can't be replaced by some generic implant or organ transplant or any of that sort of thing. And that's defining death as the loss of personal identity. And that's what I think the correct definition is, and the one that I use in the book.
So we mentioned that at the moment, there really are no significant means of hyper-extending longevity. There's potentially medical breakthroughs. We hope that there are going to be significant medical breakthroughs in the future. That seems a reasonable hypothesis. So in the book, you talk about one idea, which could be, pausing aging indefinitely by, for instance, taking someone out of biological time. How and what does that look like?
The argument is that perhaps, although we have no ways at the moment of stopping aging, of preventing decay and damage to an individual while they're biologically active, perhaps we can put them in stasis in a way that prevents those things from happening until we have future medical advances. So what would we think? Well, you can see some inspiration for ideas from nature, for example, where there's a kind of frog that lives in the Arctic where come winter, the frog freezes, 65% of its body or so turns to frozen material. its heart stops, its brain activity basically stops, and it seems to be, frozen and dead. But come spring, it thaws out and it goes back to hopping around. That's the sort of inspiration for these weird sci-fi ideas and the ideas I'm going to talk about in a moment. And what's cool is we also have these sorts of temporary preservation techniques that are already applied in part to human biology. So when we think about things like preserving eggs and sperm and embryos for IVF procedures, sometimes we're able to preserve embryos for decades before thawing them out and having them lead to successful pregnancies. So on a small scale, we know we can get it to work. Something people probably aren't aware of, though, is there's kind of a slightly analogous procedure that's done on entire human patients that's already in use in hospitals. So there's a procedure called deep hypothermic circulatory arrest, which is essentially induced hypothermia. Somebody is cooled down to 18 degrees, at which point their heart activity stops, their brain activity stops. Again, they look essentially like a corpse. But it gives surgeons something like a 45-minute to 60-minute operating window in which they can alter the delicate vessels around someone's heart or inside their brain, and then warm the patient back up again, restore them to consciousness. And it has pretty high survival rates, even with people holding on to their cognitive functions. So these are all precedents for some degree of preservation already being possible. What I then argue for in the book is that, well, maybe we can scale these things from what we can do on embryos up to whole humans. And maybe we can look at cases like the induced hypothermia, where people are stored temporarily and then revived. Maybe it would be possible to do that with whole humans for extended durations if you got the preservation techniques right. If you really could prevent the decay of someone's brain, if you really could prevent the decay of their body in an appropriate way. And there's a lot I can say on those technical details. So yeah, maybe I'll leave it there. We can hone in on particular questions.
And I guess, for instance, many people, for instance, if they were like me, a fan of, say, Futurama when they were growing up, then many people would, for instance, be familiar with things like cryonics about, freezing bodies. But for instance, we know that, no human has ever been revived from kind of these processes. How does something like that many people describe as a scam or, pseudoscience, how does that kind of differ from perhaps any of the other kind of ideas and processes, ASC that you kind of discuss in the book?
It's very understandable that people are very skeptical of any of the sort of procedures that I'm talking about or earlier ones like cryonics, because we should be skeptical of all technologies until the full technology is demonstrated, right? If I say to someone, look, I have this very impressive technology, but it comes in two parts. The first part I can show you now, but the second part, promise me it'll be available in 5 years, 10 years, 20 years. You're going to be like, why don't I just wait until you've got the second part to work before I invest or buy it or whatever? Which is reasonable. Like we should be concerned if somebody's promising something that they haven't demonstrated as of yet. And indeed, the case with cryonics, brain preservation, is the problem is that we are making this claim. We're saying we can preserve someone now with a good chance that we'll be able to revive them in the future, but we can't demonstrate it as of yet. But just, we think there's a reasonable chance it'll work. And I agree that in most circumstances, I'd be like, well, I don't want to buy that until it's demonstrated. But the issue here is that millions of people die every year. Most of those don't want to die. And so if there's something that might be able to help them, even if we're skeptical of it, we should probably be assessing the strength of the arguments for, is there a chance it'll work, or is it actually just a scam? So to get into then the technical details, there's the preservation part, and then there's the future revival part. So I'll talk about the preservation part. Yeah, you mentioned ideas like just freezing people down with the idea of being able to then thaw them out at some point in the future. Now, this has been pursued with varying degrees of sophistication at different points in time. The initial ideas were maybe we can just straight freeze people. Maybe we can just put them in liquid nitrogen, cold temperatures, and that'll work. The problem with pursuing something like that naively is that if you just cool someone down without in any way preparing their body, you'll get a huge amount of ice formation, and this ice will expand, puncture the cells, do a lot of damage to someone's body, and generally leave it in a state where it looks very damaged under a microscope, in a way where it's very dubious that you could ever restore that to health. But what that's led to is that people have developed better techniques for preserving things with cold temperatures. So cryopreservation nowadays involves, before the cooling step, the addition of antifreeze to biological material. And this is actually what's done currently with things like IVF. So when they have those embryos, they don't just straight freeze them. They add some cryoprotectant, which prevents the formation of ice and leads to better preservation as a result. The problem with trying to do this scaled up to whole human bodies, though, is that the cryoprotectants, these antifreeze chemicals, they're a little bit toxic in and of themselves. But the bigger problem is that they cause dehydration. So if you try and cryoprotect and preserve whole human organs or whole human bodies, you see significant dehydration as a result. And these cryonics companies who've been offering it, for example, if you scan the brains of these preserved patients, you'll see that their brain volume has shrunk by something like 50%. And if you image at a ultra microscopic level or a microscopic level brain tissue taken from these patients, it's not at all clear that their brains have actually been well preserved in a way where the circuitry that we think underlies memories, personalities, all those key things the brain does has actually been preserved well. It's not a guarantee that it has been destroyed. Perhaps it could be, expanded again and it would still be intact, but it's not a good guarantee at this point in time. But again, that doesn't mean that the idea is fundamentally flawed. It's just an argument for developing better preservation techniques. And the best one that I'm aware of at the moment was the technique that was developed in 2015 called aldehyde stabilized cryopreservation. So essentially, it combines the benefits of cold temperatures, which slow down and stop chemical reaction rates, with an initial fixation step, where what fixation is the addition of chemicals into a body, into an animal, where these chemicals penetrate everywhere, they get everywhere, they lock everything in place, and they prevent any further biological decay from happening by essentially fixing an animal, some tissue at that particular point in time. And they lead to very, very good structural preservation. So it's this very similar to techniques we use in neuroscience and histology for imaging tissue under powerful microscopes. And if you examine the brains of an animal preserved with this aldehyde stabilized cryopreservation or fixation procedure, it looks almost identical to brains taken from still biologically active animals examined under a microscope. So the argument then is, well, in this circumstance, we have a very well-preserved body with a very well-preserved brain. And we're saying, look, we can't reverse this yet. We can't upload or restore to biological health or in any way restore this preserved animal, human, patient to consciousness. But we think there's a strong enough argument that it could be done, that it's worth pursuing, and we can outline ideas of how maybe in the future we could revive someone. But that's the current state of practice at the moment.
When I think about the brain, obviously you're a neuroscientist, and I know you have of course, a special interest in consciousness. When I think about how delicate, neural structures are, the volume of synapses within the brain, I mean, to me, it just sounds like the intricacy and the delicacy of a procedure to be able to keep all that intact, and then to be able to, of course, to revive someone in such a way where, as you mentioned, they would still be in touch with, their essence of who they are, their conscious reality. Do you foresee that will be something a challenge that could be overcome?
Yeah, I think it's a challenge that could be overcome, because I agree that obviously humans depend, our ongoing survival depends on the maintenance and integrity of our brains and their 86 billion neurons and their quadrillion synapses, that it is possible to foresee ways in which those could be kept intact in a manner compatible with reviving someone. The first thing I would note as well, though, is as delicate as those structures are, people do routinely survive injuries to their heads. Things like concussions, which can cause quite a bit of damage. Things like cardiac arrests, where you can have periods of no oxygen, swelling of the brain, all sorts of sort of problematic issues. And then individuals can be restored to consciousness and maintain cognitive function after then. Which is just to say that like brains are very delicate, but they're not like impossibly delicate to the point where any aberration, any change to them inevitably immediately kills a person and destroys their brain. There is some degree of manipulation that they can withstand. So the point I would say is that the procedure that I'm describing, this fixation procedure, essentially what it does is it does involve capturing all of those synapses, those connections between neurons in very exquisite detail, and then preventing them from really suffering from any further damage from that point onwards. So the fixation process gets in, locks everything in place, and then means that even if you do some quite serious interventions later, like you take the brain out and you slice it, and you image those things under an electron microscope, you can still image all the way down to the level of individual connections between neurons, while still seeing that they're maintained in good structure, in a way that allows you to do things like trace the neurons, trace the connections between different neurons, work out what different kind of synapses they were. Because the initial preservation step locks everything in place and makes it quite strong and static. At the cost, obviously, of preventing what a brain normally does, which is dynamically change itself all the time while it's biologically active. Which is why we can't reverse that yet while still keeping it intact. But I see ways in which it could maybe be done in the future.
So if we just kind of pick up on a few things you said there, so we're talking there about, imaging, slicing open brains, really get into the kind of heart of neural structures, synaptic structures, and kind of trying to piece all that together. So we do all that. We come up with a kind of a specific diagram of an individual's connectome, as you write about, in the book. What do we do then? Where do we go from there?
Okay, so I think what you're getting at is like, how would you imagine using a preserved person's body to actually then revive them in the future? And one idea for how we could do that is perhaps by uploading someone, by taking their old biological brain and using that to recreate them a new artificial brain, whether that's a digital, electronic, computer version, some new version of that brain. That's one idea that's been explored for a potential method of reviving someone. So the idea here is that you can actually see a fairly straightforward, if not still odd, extrapolation from current technology to a future time point where maybe that will be possible. And the idea is, one idea of how you might do it is you would take someone's brain, so there are 86 billion neurons, quadrillion synapses, and you would extract it from someone's skull. You would then image it at very, very high resolution, almost down to the molecular level. And you could do that using a technique, for example, called electron microscopy, where you get like 10 nanometer-ish resolution from these beams of electrons being bounced off bits of brain tissue. As you alluded to, though, it does at the moment, it takes a long time. So in order to speed it up, what you'd have to do is slice the brain into many thousands of slices and image each of those slices in parallel. It also sounds a bit disturbing. What you would then do, though, once you captured all of this information, is you would reconstruct it back into a three-dimensional map of all of someone's brain cells and the connections between them and the kind of brain cells they were. And we call these like full maps of brain cell connections connectomes. The same way that we call the full set of someone's genes their genome, the full set of someone's synapses is their connectome. And each different person's connectome differs. That's why I have my memories and you have your memories. I have my personality, someone else has theirs. The idea, though, is that this static connectome that's just like existing in storage on the computer that's done the scanning procedure, it, when it's static, doesn't do anything, though. In the same way that someone who's in hypothermia, whose brains become electrically inactive, is just unconscious. They're still there in the sense that their brain structure, what makes them is still there, but it's not currently active in any way. So what you'd have to do is you'd have to take this connectome information and you'd have to put it back into a physical format that had some sort of dynamism to it, that could change and alter itself and do the processes that we think are important for consciousness. Now, whether that's putting it into an electronic brain in a robotic body or a digital brain in a virtual environment, you can speculate on either of those. But the idea is you could do perhaps something that's called a whole brain emulation, where it's a technical term for something like mind uploading. But what you would do is you would essentially perfectly recreate, at least down to the level of like subcomponents of neurons, the causal mechanisms that the brain used to use, so that you would have this emulation that would function pretty much the same way that the original biological brain did. And the idea is, and the argument that's being made is, if you got that right, then you would indeed capture all the processes that are important for consciousness, as well as memories and everything else, and restore a person to consciousness that way. Now, I'm aware that there's a lot missing from that to make the argument stronger and to get into it. And this is just a short podcast, but that's the brief overview of the idea.
Do you think that consciousness could survive without a physical body?
I think consciousness, in the absence of some sort of physical body to instantiate it, is unlikely to be the case. But I would say that doesn't mean there aren't still lots of ways that consciousness could potentially come about. So if you, in a philosophy sense, if we're thinking about consciousness in the absence of a body, really, as far as I can see, the only option available to you is something like dualism, the idea that there's a soul that somehow gives rise to consciousness. But if we're talking about different ways physical things can give rise to consciousness, there's all sorts of different formats. I mean, biological human bodies are physical things, but computers are also physical things. Digital brains would still be physical things that have to have processes that give rise to them in some way, shape, and form. And I think many philosophers and neuroscientists are open to the idea that it's not just necessarily human biological brains that give rise to consciousness. Many other animals may be conscious, aliens might be conscious, and AIs are either may be conscious today or definitely could probably be conscious at some point in the future. So I don't think it's just biological human brains that necessarily are conscious.
If I was to, follow one of these, procedures, if, someone was to, I'm not sure why they would want to, but if they were to do, for instance, an emulation of my brain, and they were to, for instance, upload it into, an AI system or into a robot system, and it was to be perfectly mapped, would that still have the essence of me if it wasn't connected to, for instance, all of my physical features? That was the question I was wondering.
Gotcha. Yeah, I mean, I still think that you would need to embody a brain in some form for it to work, either at all or at least well and in the way we would want it to work. Because, the point of having a brain, again, in an evolutionary sense, is to control a body so it can go around and do stuff, whether it's find food, find mates, find friends, avoid damage, any of those sorts of things. That's what we do. We're not just consciousnesses disembodied. And I think that if you were trying to upload an individual, emulate them in some form, they'd still need to have inputs, sensory inputs coming in and motor outputs going out. Now, in the same way that with the sort of prosthetic limbs that we have today, I don't think those things necessarily need to be controlling biological material. You could imagine the emulation being given control of a robotic body or a virtual body, but I do think it would need sensory inputs and motor outputs in order to function appropriately. So yeah, I don't see a future in which we have disembodied consciousnesses. To be honest, I'm not even sure what it would be to be a disembodied consciousness that didn't have some sort of body it was controlling. There are ideas in philosophy that explore it, but they seem very odd. And not from a life extension perspective, definitely not what we're aiming for.
Within the scientific community, how have, for instance, these ideas been met by, for instance, your peers, your colleagues, by other people within the neuroscience or philosophy? How have people kind of viewed these ideas in those other fields? It's
interesting. Each of the individual elements I'm talking about, like what causes aging, what's aging biology, what is personal identity, how do we maintain ourselves over time, what is consciousness, How can we have good preservation techniques for brain imaging? What is the costs and health economics of any sort of new procedure? All of these ideas have substantial individual treatment and articles or books dedicated to them. And so there's very little of my own original research in the book. I am mostly exploring other people's ideas. But what's different is that before my book, there hadn't really been an overall synthesis of could something like brain preservation for life extension work? And what are all of the elements required to go into it put into one picture? So I was curious as to what people would think once I actually made this argument, putting it all together. Now, the book's only been out for a few weeks, so I don't know yet what the overall response is going to be. But I do have some feedback on some of the questions that I was asking in the book that hadn't previously been asked. So in particular, I recently ran, in conjunction with some colleagues, a survey of a few hundred neuroscientists asking them, do you think that we could ever extract memories from a preserved brain? Or even, do you ever think we could produce a whole brain emulation, essentially something like an upload, from a preserved brain? Now, I didn't ask them tricky questions of what do you think the nature of consciousness is? Or should we ethically be doing this? Because I just wanted to focus on the technical questions of could we produce a whole brain emulation from a preserved brain? But the responses were quite interesting. So there was a huge variability of people's responses where some neuroscientists were like, absolutely, yeah, I think high probability to work. And some people were like, no, that'll never work. Brains are too complicated. We'll never be able to capture it. But the average response from people for both can memory be extracted, and specifically, could we ever produce a whole brain emulation from a preserved brain, was 40%. So that's to say, they don't think it's guaranteed to work by any means. And it would be disingenuous for me to say that, even if I personally think the probability is higher. But they definitely don't assign it a 0.1% or a negligible chance. They think there's a substantial chance that something like this could work. For me, that's some evidence that this makes it something like a risky but worth considering medical procedure, where if the alternative was definitive death, it might be worth considering. And we can see what sort of research would still be required to maybe bump that number up from 40% to 60%, 80%, or to show that it'll never work and that we should drop it down to 0. But yeah, that's essentially where I'm at so far with medical, philosophical, neuroscientific opinion. I hope to hear more from my colleagues over time, though.
Are they from, is it going to be something in our lifetime that, for instance, becomes widely available? Where are we, for instance, on that distribution front?
There's the preservation, and there's the revival. Now, revival, I don't think we can do anytime soon, whether it's through uploading and whole brain emulation, or whether it's through direct, revival of biological, like a whole human body. Maybe the uploading, I do look at some extrapolation and timelines, maybe as early as the 2050s if things went extremely well. But in that survey, when I asked people, they guessed more like 2120 or so. So that's still a long time away. But in terms of the preservation, I actually think we can be preserving people now. Like the terminally ill could be preserved with these techniques that have already been developed. And that the main issue is actually just providing access to them and rolling them out as part of the medical system. That's one of the main reasons why I wrote the book, is that I want people to be aware that these things exist. They have some substantial chance of working, and that we should be providing them to those who are terminally ill so that they could take it up if they wanted to. In terms of actual providers, like if you unfortunately were terminally ill, or if I were terminally ill and I wanted to take this up, there's a couple of groups on the west coast of the US that are one is kind of already offering it, although it's kind of tricky to access. Another one is planning on offering it, I think, starting next year. And there's one in Europe that I'm a little unclear as to whether they're offering the particular better procedure that I'm talking about or just some of the earlier procedures. But there are small groups that are starting to provide this. And I hope over the next year, at least, to see it become more widely available. But I think one of the limiting factors has just been a lack of demand for it so far. So if people are keen, it can definitely be scaled up.
Right. And I certainly, as I said, I give you a lot of credit for writing this book because, if someone does want to, for instance, if someone is intent to do this, they should certainly know about it and they should be able to make an informed decision. Whether someone would, of course, want to, for instance, go through it. And of course, there are certainly ethical, social things to discuss that, as I said, we could spend 10 hours chatting about, that's up to them. But I think it's brilliant to, for instance, bring awareness to this. So I just want to just ask you a couple more questions before I ask you to sign off and tell these guys where they can connect with you. So if someone, for instance, they've listened to this podcast, they've now intent, they want to go out and perhaps read your book and, perhaps delve further into it. What would perhaps be one point from the book that you would love people to take away from this?
I think the key one is one we've already sort of touched on, which is that most people would like to live longer lives than they're currently able to live. Most people on their deathbeds wish that they had something that would enable them to have their lives be extended. And that this is not something that's going to go away. It is a desire that people generally have held, and I think will continue to hold, and something we should be working to help people with. Because I think the point of all medicine is to grant people more autonomy over their health and over their lives. And I'm not saying that we should give people inescapable immortality, that we should be ensuring people have the choice of death taken away from them permanently. And I'm not saying that we should ignore the broader social and ethical issues that come along with this, how societies would change, what the economic implications would be. But I am saying that we should go from a world which we currently have, where people have to die, where there's nothing they can do about it, to one in which people have more choice over their health and more autonomy over their health. Because I think that's always, with all medical research, all medicine and healthcare, what we should be striving for.
I love it, man. And the final question that we sign off all of our podcasts with before I ask you to tell these guys where they can connect with you is, for Ariel today, what makes a life worth living?
I just think it's the same people, same things humans tend to love. I love spending time with my friends and family. I love going to the beach. I love eating ice cream, love reading books, love having fun conversations with people like you. I love seeing the world improve, where we've gone from a world where 1 in 2 children used to die before the age of 15, and one in which most people lived in extreme poverty, to one in which, there's still huge challenges that exist today, but there's a lot of people working to meet those challenges. And I think a reasonable chance that we will actually succeed in producing a better, richer, healthier, more equitable world in the future. And it's an absolute privilege to get to live now and to get to work on improving those things and to get to enjoy the benefits of civilizations that our ancestors worked so hard to produce.
Tell these guys where they can connect with you, where they can get the book, and any other closing messages. And of course, we will link everything below in the description.
So you should be able to get the book anywhere one normally gets books: online, Amazon, websites. My personal website, arielzj.com, has all those details as well. I'm on Twitter and Blue Sky at arielzj, I think. It's also linked on the website. Standard. Give it a Google and you'll find me.
I love it. And I just want to thank you once again, Ariel. I feel as if you've sparked a real conversation with this book. And, I admire the bravery, the conviction, the passion that you wrote it with, the depths of research. It's obviously a hugely complicated, complex topic with a myriad of levels, but I think you've really sparked a conversation with it. So I really thank you so much for writing the book and for taking the time to come on the show and to enlighten myself and our audience.
Oh, thanks for the in-depth conversation. It's always fun to dive into these details, and the questions have been good. So it